Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on what linearly independent and dependent, where they have given set of vectors. Considering those set of vectors, we are going to represent it with respect to linearly independent or not. How to represent, or let us see. To define linearly independent, whatever they have given the vectors, that is v1, v2, v3, where c1 v1 plus c2 v2 plus c3 v3 etc. up to cn vn, which will be equal to 0. This, in this term also we can find, or else if c1 which is equal to c2 equal to c3 equal to 0, if every scalar factor is equal to 0, we call it as what? Linearly independent. Or else, considering this vector, we can represent the matrix. If you don't get any zero row, then we can directly conclude it as the given set of vectors are linearly independent. Okay, now let us solve. First, since they have given the vector with respect to v1, v2, v3, let us go with the condition itself, where we know that c1 v1 plus c2 v2 etc. up to cn vn equal to 0. If it is linearly independent, every element of scalar factor will be equal to 0, or else it will not be equal to 0 for the linearly dependent condition. So what we are going to consider, only three set of vectors, that is c1 v1 plus c2 v2 plus c3 v3 equal to 0. Now what we are going to do, let us represent the vectors v1 which is equal to 1 4 9 and v2 which is equal to 3 1 4, or else v3 which is equal to 4 3 12. Yes. Now multiply with respect to scalar, c1 into 1 4 9 plus c2 into 3 1 4 plus c3 into 4 3 12, which is equal to 0. Multiply the scalars, c1 plus 4 c1 comma 9 c1 plus 3 c2 comma c2 comma 4 c2 plus 4c3 comma 3c3 comma 12c3, which is equal to 0. Now add the term by term function, that is c1 plus 3c2 plus 4c3. Next, the second term, 4c1 plus c2 plus 3c3 comma 9c1 plus 4c2 plus 12c3, which is equal to 0. Represent this in the linear equation form, that is c1 plus 3c2 plus 4c3, which is equal to 0. Next, 4c1 plus c2 plus 3c3 equal to 0. Next, we have 9c1 plus 4c2 plus 12c3 equal to 0. Now, considering the system of linear equation, we are going to represent it in the what? Augmented matrix form by using what? Reduce it into Gauss elimination method. We solve the system of equation by Gauss elimination method and the associated augmented matrix is given by, that is represent the matrix only, since RHS part is 0, so let us consider the only LHS part with respect to coefficient, that is matrix A, which is equal to 1 3 4. Next we have 4 1 3. Next we have 9 4 12. Now reduce this matrix into upper triangular matrix. How? Since first element is 1, just reduce R2 dash changes to R2 minus 4 times of R1. What we are going to get? 4, 1, 3 minus 4, 4, 4. What is R1? 1, 3, 4. That is 4 minus 4, 0. Always use the calculator for the perfect and exact solution so that there will be no mistakes. 1 minus 4 into 3. You get minus 11. Next we have 3 minus 4 into 4. You get minus 13, which is equivalent to 1, 3, 4, 0, minus 11, minus 13. Next, with the third row, that is R3 dash changes to R3 minus 9 times of R1, which is equivalent to 9, 4, 12, minus 9, 9 times of 1, 9 times of 3, 9 times of 4. 9 minus 9, 0. Next we have 4 minus 9 into 3. We have minus 23. The last 12 minus 9 into 4, minus 24. 0 minus 23 minus 24. See what next we need to do? See below the diagonal element, that is minus 23, I need to make it as 0. So what we are going to do? R3 dash changes to, I am going to multiply 11 for R3 and 23 for R2. That's it. 11 times of R3 minus 23 times of R2, which will be equivalent to 1, 3, 4, 0, minus 11, minus 13. 11, 11, 11, 0, minus 23, minus 24, minus 23 into 0, 23 into minus 11, 23 into minus 13. What we are going to get? Anything multiplied by 0, 0. Next, minus, see, minus into minus plus, this get cancelled, get 0. The last term we have 11 into minus 24 minus 23 into minus 13. We get 35. Okay. See, now represent this in the linear equation form, or else we can conclude here itself. If you are getting a non-zero row in a matrix, then we can directly conclude this given set of vectors are linearly independent. Or else, since we have gone with respect to C1, C2, C3, let us represent C1 plus 3C2 plus 4C3 equal to 0. Next, minus 11C2 plus minus 13C3 equal to 0. Next, we have 35C3 equal to 0. Consider this as equation 1, equation 2 and equation 3. Therefore, consider equation number 3, where 35C3 equal to 0, C3 will be equal to 0. If C3 equal to 0, then C2 is also equal to 0 and C1 is also equal to 0. If C1, C2, C3 is also equal to 0, therefore we can conclude directly, I have told that everything will be equal to 0. Therefore, the given set of vectors are linearly independent. That's it. See, this is how we are going to represent. Here itself you can conclude. I have told in the beginning itself that after reducing the matrix, if you are getting every non-zero rows, if you are getting 0 rows, you get, we call it as what? Linearly dependent. If you are getting the non-zero rows, we call it as linearly independent. See, we have non-zero rows. This also is non-zero, non-zero, non-zero. or else if you don't go with respect to this also, if you represent directly with respect to matrix form, again you will get the vectors are linearly independent itself. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.